Hi, Eric here from Laserscanning TV, and I'm together with.
Yeah, hi, Jannis.
And yeah, I think you have special tasks. And what was your task here in our company?
Yeah, my task was to test the accuracy of SLAM scanners from CHCNAV, and therefore I did some tests indoor and outdoor with the GNSS module.
Yeah, also they have a very good GNSS module integrated in their SLAM system, and we was interested to figure out what is the performance of the system. And if you are also interested, what is the results? Stay tuned. Yeah, Jannis, before we start, maybe you talk something what is about yourself so that maybe people know a little bit about your story.
Yeah, hi, my name is Jannis, and I'm studying geomatics at the State University of Applied Science in Dresden, Germany. And besides my study, I'm working at LSE and do often some accuracy testing with mobile scanners.
Okay, then let us start with your test.
Yeah, so my task was to check the geometric accuracy of the mobile scanners from CHCNAV, and therefore I did some testings indoor and outdoor. And yeah, for outdoor applications, we can see the scanner has a quite big GNSS antenna on the top, and at the bottom, we can see here we can hold up the GCPs if we have some while we are scanning.
Yeah, or maybe like CHCNAV is yeah, a Chinese producer of survey instrument, is a large company, have 20 years experience in GPS receivers development, and they make this integrated GPS SLAM system. I think in this kind they are the only one who have such deep integration. And we was interesting, is this the right choice for topographical survey? But let us start with our indoor testing.
So let's start with the indoor. Here we can see our test field and its extensions, and we see here the green points. These are the ground control points which I use to reference the scans in the local coordinate systems of the hall. After that, here I compared the point clouds from the Faro Focus and the RS10 and did some sections in PointCab and measured deviations. And here we can see the highest deviations with which I have found. And here we got deviations in position up to 2.3 centimeters.
Yeah, let us say something to the picture. One point is that we say the image resolution is 5 millimeters, so this means that pixels are not below, also we have not millimeter detailed displaying of each pixel. So, like, of course, we have 5 millimeters, and of course, even the Faro Focus, who's a very accurate terrestrial scanner, it's not super perfect. There will be also some 3D. I think the 3D accuracy is maybe 4 millimeters or something from the system. And then, of course, we have 3D accuracy of CHCNAV or range accuracy, because the working with an SI unit is maybe 10 to 15, 13, 14 millimeters. And if you put everything together, like the two deviations of two scanners and the pixel and so on, it's maybe 2.3 centimeter, the logical arrow what you can have. So I think that's already a good results.
Yeah, right. So let's move on to the height investigation. I also analyze it in PointCab, and most of the hall shows low deviations. And here in the area marked in red, we got a little bit higher deviations up to 2.1 centimeter, which is also not that big. And here's
Yeah.
another screenshot from PointCab where we can see some measurements.
In this
Yeah.
wet area or special area, because we had previous videos where we compare K1 from X grid and L2, and we saw there was deviation between K1 L2, and this is now our special area of interest, because we don't have, it's like an deaf ray or something like, so it's on the side and we have no GCP inside, and our estimation was that maybe the maximum error will be pressed by the calculation in this area. So that's is the reason why we have a focus on that. And I think with this, what we have 2.1 centimeters, we the same actuate like with the other SLAM scanner in this special area.
I did another comparison between the Faro-Focus and the RS10 in Cloudcompare. And Cloudcompare, yeah, got a cool tool where you can compute cloud-to-cloud distances, and there the differences are visually really good, recognizable. And yes, here is the color scale which I used, and here are the pictures. Here you can see different views from the hall, here from side, top, and the bottom views. And we see that we got quite good deviations. Yeah.
Yeah, from the scale, it was, I think blue was up to 5 millimeters and green to 1.5, and yellow was from 1.5 to 2.5. So this means it's all in what we expected. There's also many blue areas and green, also many of green area. Especially inside a little bit more. I think that's maybe from the high, and then we had also some inside. I think there was also some gates or not gates, like fences for the robots.
Yeah, there are some fences and
fences, and then we have also windows. That means that we saw there's some red areas there. I think it's maybe double reflection, stuff like that. So
yeah, the walking way was just here and the outside. Yeah.
So can be double measurements. So, but in basically we are many areas 1.5, but definitely many areas below 2.5. So what we expected. So quite good results.
Yeah. And yeah, let's move on to our outdoor accuracy testings. And here we can see our first outdoor test field.
Okay, and for the audience, they are attentive. Now we are switched the system. So indoor we was with an RS10 from summertime, and now the outdoor stuff we do with an RS30. And maybe Jannis, you told audience what is the difference between 10 and 30?
Yeah, the difference is that RS10 have a 16 channel LiDAR, and RS30 32 channel LiDAR.
Yes.
And there's some difference in the how many points are measured in 1 second, and I think maybe in the
I think the range
in the range.
range.
Mm.
Yeah, I think it's maybe longer range.
Yeah, right.
That's a good point.
Yeah.
I have to ask. We don't can answer this if you have a longer range. Also already the small scanner have 120 meters. Maybe the bigger one have more. But the question is if the producer using the whole range for SLAM registration, or very often they use only a shorter area for using this for SLAM. But actually we don't can say it. Maybe we get this information. So okay.
Yeah, here's the test field, and we already see 7 checkpoints which I have measured before scanning, and here we see I measured them with the MLID RX, and yeah, I selected easy recognizable points here, such as edges, which I can later click easily in the point cloud.
Yeah, one question. If you just use it for scanning, you walk there, or you use like skates or like a skateboard?
I was just walking, but
okay, it was walking. So. Not mobile scanning with wheels. So, but let us come to the results.
Yeah, exactly. Here, that's the evaluation, and I processed the scans in Copri 2, which is the LiDAR processing software from CHCNAV. And I processed the scans without the influence of GCPs. I just used the RTK data. And yeah, then I did a comparison between the coordinates here, which I measured with the MLID RX, and the coordinates which I got from measuring in the point cloud of the RS30 in Copri 2. And yeah, in Copri 2, there's a function that allows you to simply select the point coordinates with the mouse. And here on the left side, we can see the deviations. Here, the mean position deviation, 1.6 centimeter, and the mean height deviation, 1.5, which are good accuracies. And here on the other side, I did a comparison between the MLIT RX coordinates and the coordinates which I got from the CHCNAV report. And this report you receive after the processing, and there you can pick out the coordinates and compare to the other ones.
On the right side, that's points where you use this ground plate from the RS30 and measured this point.
Yeah, right.
And the same area used in the antenna to, and there we have on the right side, we have a little bit larger deviation between both measurement. And the height deviation is super good for my feel. And on the left side, we're picking only points in point cloud. And I think for my feeling, it's maybe on the right side. Maybe because of we setting up the system on the ground, and then we put a 2-meter high pole with the RX. It's maybe some of the deviation. It's the little bit the inaccuracy from our how good we can catch this point by setting up. So I think it's maybe not the most super what you would say a laboratory researched way, but of course it's a field test there. So but on the left side looks pretty good. So that
and the 3.9 centimeters seems a little high, but we have to keep in mind that we are still talking about RTK accuracy, so it's still okay. Yeah.
But usually there should be the high deviation higher as the XY deviation, so in RTK.
Yeah, that's right. Normally the height deviation is bigger. Yeah, then we come to the test at the HTW in Dresden.
This is the like the part of the building of the university, let us call Applied University. So this area, and I maybe can talk while we choose it. So CHCNAV told us there's a capturing workflow where you can use GPS, but also poor GPS condition, and the system decides himself when he used the GPS coordinates and when he don't use the GPS coordinates. We have some areas where we have some trees and high, also the office building is super high. I think it's 4 floors, or there's high floors, also not super high, but it's larger building. And then we have also 2 underpasses, where we definitely not will have GPS positions. So, and that was the reason why we choose this area for our testing, right?
Yeah, exactly. And here in blue, we can see some checkpoints which I measured before. And and CHCNAV has a scan option which I used while I scanned, and that allows indoor and outdoor areas to be captured in one single scan. And that was perfect for our test. As Eric mentioned, we had here the underpasses, so we need a function, and we wanted to test it. And so, on the right side, we see the point cloud from Copri 2. And here the numbers which start with a 1, the 100 numbers are fixed points from fixed point field from my university, and these have really accurate coordinates which were measured with a total station.
Yeah, that's not we measured this. So this grid points with the 100 number is university grid. What is measured with total station and adjustment. So it's part of their network. I think it should be a couple of millimeters or from the accuracy.
Yeah, they get really high accuracy. Yeah. So here we see the measurement from the control points. Here is the same as here the Skatepark, and we see the underpasses where we don't get any really bad RTK data. And at the next page, we can see here the blue areas represent the GNS data, which is used for in the processing, and the red ones aren't used in the processing.
Yeah, and we can very good see that we have on the on the upper side, so this area where we have this one underpass is this red area, and then we have below to the other passes and close to these high buildings, and also there on the right side there's also a high building, and on the other street side is a lot of trees. So I think that was the time before there were some leaves was on the tree. I think you can see it. So I think that's definitely not the perfect GPS condition. So and CHCNAV decided to not use this GNS data, or I don't have one.
No.
Okay.
Right. Yeah, so let's get back to the evaluation, and I proceeded in exactly the same way as with the skate park. Yeah, here on the left side, we see the deviation, which I picked from the point cloud. And we see here now we got some little better height deviations.
So yeah, now looks left side more like typical GPS conditions. So very good
right.
position, and the height is not so the perfect. So also it's a little bit less. So it's what you estimated from GPS measurement.
Yeah, right. And on the right side, we see here the deviations from the report. And when I hold it up the GCPs, and here we see it's about 2 centimeters. Yeah.
And in our last interview, in the German one, I asked him a question because we have these hundreds of numbers, and what accuracy, because it's a mean position deviation over all points. So, and then we pick up a point who was close to the underpasses, and I think we already got there, it's like 1 centimeters, these 174, yeah, and we had, I think if I estimate
this
it
one
was
we took,
1 millimeter for, no, below 1 centimeter for the XY coordinate, and the high was 4 centimeters. So
yeah, exactly,
yeah,
right.
quite good. So I'm super surprised from these results. So.
Yeah, so after that, I processed the scan again, but now with the influence of GCPs. And therefore, I used here the GCPs from the fixed points from the HTW. And yeah, we can see that we got some better results now.
Yeah, okay, now we have lower numbers, so more accurate.
Yeah, right. And lastly, I did a comparison between the deviations of control points with and without the influence of the GCPs. And here on the left side, we have without deviations without the influence of the fixed points. And here we got 2 centimeters. And on the right side, we see deviations with the influence of the fixed points, and we see we got better results.
Okay, and this would be mean it's maybe useful to have some additional references, right?
Yeah, right. So the RTK module can produce good results, but we can improve it when we use GCPs while we are scanning. Okay. And use both the GCPs and the RTK, so we can get really good results. Yeah.
Okay. Is this our final takeaway or for this, or?
Yeah, that's our conclusion.
Yeah,
so
our conclusion is, I can say one conclusion is we got very good results out, what I was not expecting to get. So for the RTK use, and my original estimation was this is very good if you want to do volume calculation in mines or for road survey, so where you maybe need good accuracy but not the highest. So, but now we are in accuracy where you easily can do something with topographical survey. So that surprised me. And from the workflow point, we already get good results out with only the RTK model without any GCP points. But if you put the extra effort inside 4 GCP points, then we maybe get an increasing accuracy. And they have a very good capturing way. If you're using this indoor-outdoor massive of the system, you can also go close to areas where you don't have GPS and you don't use GPS, and still there the system works and deliver a stable point cloud under our condition. Yeah. for me it's very interesting about the total results. So because I started, I think, for maybe 4 or 5 years. So there was GeoSlam to that time was the first who had an external GPS receiver. I think was working basically with different system, but I think they had integration for Trimble and also later for Emlet, if I remember right. When we do there some testing, but we're not going in this accuracy path what we see here now. So we see there is some further development over the last year from this producer here, and for me looks like that this is definitely maybe an option to do some topographical survey based on the SLAM GPS system for maybe surveyors they like to be more efficient outside. So that can I assume from this presentation or from our research. But I think it's maybe you need your own investigation before you use it. And I would definitely, because SLAM is very often a black box. I would recommend it somebody to have GCPs or extra points, which you can use for control, that you're not working complete by this until you have very good feeling about these outcome over maybe many projects. I think in the beginning is not wrong if you make your measurements and then maybe you use the GCPs and you have a control inside, because with the CHCNAV you can do both. You don't need an additional GPS receiver. You can use the internal, you can use the scanner also as GPS receiver, can take the points, and then you can use it as a GPS used SLAM system. So I think that's maybe our suggestion to test it is. So, and for people from Europe or from Germany who are interested in CHCNAV products and SLAM, they can contact us. And for anybody else, maybe check out the CHCNAV website, who is maybe your closest dealer if you're interested to check this device out. Yeah, I say many thanks to you, so for Jannis, for your research.
Yeah, you're welcome.
And we say bye bye. And for the audience, it's important. What should you do?
Yeah, stay tuned, like the video, and write a comment if you're interested.
And subscribe to the channel. Let us grow. I think we need something that we have 4,000. So maybe you want to send me a Christmas present. I say bye bye until the
Yeah,
next
bye.
until the next episode.